Hello everybody, hello. This is Radical Dude here. It's time for another episode. We're doing some math. What we have now, what we're going to talk about is special angles in trigonometry. So first we're going to complete this table. We're going to have an angle theta, and we're going to talk about sine theta, cosine theta, and tangent theta. Right? These are the three main trigonometric functions. Or at least that's what they told me in school. The angles we're going to do are 0, 30, 45, 60, and 90. Those are the angles that we're going to do. So you copy this down and then we'll fill it out. Everybody get a chance? Good. I forgot you could put pause on the computer. So, to start, you have to know the basics right here. Y, X, and R. I'll make these the sides of the triangle, and this is theta, right? It's the Greek letter theta. I want you to tell me what is sine theta, cosine theta, and tangent theta. Well, very simply, if you look at it, sine and cosine are the only ones that deal with the hypotenuse. Hypotenuse is R. That never changes, right? That stays the same no matter where you are in the triangle. This is the hypotenuse. And it always goes in the denominator. Okay. Sine is opposite over the hypotenuse. That gives you y. So the only choice for cosine is x. And then tangent is defined as sine over cosine. And when you divide these, it's y over x. Or opposite over adjacent. This is the basics that you have to know to start this special relationships. Okay. Remember, sine is dealing with y. So let's go back to our chart. Here we go. Now remember, sine is dealing with y. So we're going to start by looking at sine of 0 and sine of 90. Okay? So watch what happens. As this angle goes to 0, what is happening to the y? Yeah.
Oh, here. What are you doing?
I'm making videos. These are going on YouTube. Sorry about that interruption there. That was one of my bosses. Okay. So where were we? We're looking at sine of 0 and sine of 90. What you have basically is this. As sine deals with y, as the theta goes to 0, as this gets smaller and smaller, the y also gets smaller and smaller. So as I'm drawing this to 0, as this is approaching 0, this angle, this y gets smaller and smaller and approaches 0. Also, as the theta is getting larger, as this theta gets larger, the y gets larger, right? Think of it as a sharp bite. As the shark is opening his mouth wider and wider and wider and wider, the y gets longer. Okay? So, we go back here, and sine theta, when it gets to 0, sine of 0, we discussed is 0 over r, which is just 0. And at 90, it is 1, because the y gets so large that it approaches the radius, or the hypotenuse, I should say. It's the radius on the unit circle. Now let's look at cosine. Same thing. This time cosine deals with the x. As you go to 0, this r gets closer and closer and closer to x. They merge. They become the same. So therefore, r, are you guys listening out there? R and x are the same. So what happens is we have 1 here. And then when it goes to 0, when this goes to 0, you get the 1. And when it goes to 90, you have x starting to approach r. So then it becomes 90. And I keep hitting the wrong one. So then this will be 0. Is the red. Now tangent is just defined as sine over cosine. So if you divide 0 over 1, you get 0. And if you divide 1 divided by 0, it's undefined. So this is undefined. Just write the word undefined. Let me check to see if it comes out. All right. Now we're going to look at the special triangles, where we get these angles. So, first thing you do is you say, we're going to use the 30 and 60. So what I draw is I want to draw an equilateral triangle. And as you can see, that doesn't look as good. Let's try it. That's better. Make it equilateral. All sides are equal. And that means that each angle is 60 degrees. That's nice. Now, I can drop an altitude that makes 90 degrees. And if you notice, this is reflexive. It's congruent to itself, like looking in the mirror. This is the hypotenuse. So these two triangles are congruent by high leg. That is when the leg lifts high. Here we go. Hypotenuse, leg. So these two triangles are congruent. Therefore, all the corresponding parts are congruent. So this angle is congruent to this angle, and they are both 30 degrees. Those angles are both 30 degrees. Let me just take the time and everything off the camera. There we go. Now, you can call this any letter you want. We can call it whatever. So, here's how we're going to do this. If I call this x and this whole thing is x, correct? Then this is half of x. This little piece on the side is half of x. But we don't want to use half because most students don't like fractions. They're afraid of fractions. So if I want to make this x instead, and then this has to be x, then this has to be 2x. And if this is 2x, then this is 2x. And then this is 2x to keep it equilateral. Now we've just gotten rid of our fraction. Here's what you're going to do. First is, you're going to say, what do you want to call this altitude? You can use any letter you want. Do not use the letter x, because then you're assuming it's the same size as this side. So you can't use x. Don't assume. That's what I did. I assumed my wife loved me. And after she left me, I realized not to assume anymore. So we'll put this down here. You can use whatever letter, and don't use the letter O, of course, because that looks like a 0, which is what I think of her at this moment. So I'm going to use y. So looking at one triangle right here, I have y, 2x, and x, and I want to show the relationship between these, so I'm going to use the Pythagorean theorem. So y squared plus x squared equals 2x squared. Multiply that out. This is 4x squared equals x squared. Y squared. You want to get y squared by itself. That's 4x squared minus x squared is 3x squared. And then you take the square root and you get radical 3, and radical x squared is just x. So all this comes out to is x radical 3. So this is now x radical 3. Okay. Now we can do sine of 60. This is 60 degrees. Okay? So, sine of 60 is x is opposite over hypotenuse. X radical 3 over 2x. X radical 3 over 2x. Okay? What happens now? The x's cancel, and I'm left with radical 3 over 2. So sine 60 is radical 3 over 2. Now we do cosine 60. Cosine 60 is adjacent over hypotenuse, so that's x over 2x, and that comes out to a half. It's not 2, it's a half. The 2 is on the bottom. So we have sine 60 is radical 3 over 2, cosine 60 is a half. Oh, I'm always getting interrupted. Yeah. I keep getting interrupted. Right, I'm back. Sorry for the interruption. So tangent now. Tangent 60 is opposite over adjacent, x radical 3 over x, which is just radical 3. So now we can go back and fill in the chart. Here we go. So sine of 60 is radical 3 over 2. Cosine of 60 is a half, and tangent is radical 3. Now we have to do the 30 degrees. We're looking at 30. 30 is up here. So let me erase some of this so we can see. Doing sine 30 is opposite over hypotenuse, which is a half. Cosine 30 is adjacent over hypotenuse, and these x's cancel, and that's radical 3 over 2. Tangent 30, I think you already did 60. Tangent 30 is x opposite over adjacent, and that comes out to 1 over radical 3. 1 over radical 3 is fine for me, but most times mathematicians don't like a radical in the denominator. I have no idea why they don't like a radical in the denominator. Radical in the denominator is fine for me. I won't mind it. I'm sure you at home don't mind it. but they don't like it. It doesn't feel good to them. So how can I get rid of this radical in the denominator? They multiply to rationalize the denominator, multiply by the same number in the denominator. The top becomes radical 3, and the bottom is radical 9, which is 3. So this is radical 3 over 3. Now we go to our chart. The chart, here we are, and now we fill in our table. The one we just said, tangent of 30, was radical 3 over 3. The sine of 30 was a half. The cosine of 30 is square root of 3 over 2. And all we're left with is one more thing, the 45s, and then I'm going to show you a trick to memorize this table. 45. So, to get the 45 degree, I'm going to use an isosceles triangle. I'm going to make it a right triangle, an isosceles. So I call this X and X. You pick whatever letter you want to use for there, except for X and O. So you can call it Y, R, whatever you want. I'll call it R. So how could I find R? Well, I'm using a Pythagorean theorem. X squared plus X squared equals R squared. Now when I add X squared and X squared, some kids make the mistake, say it's X to the fourth. Just remember, you're adding, if you have an MP3 player and another MP3 player, then you have two MP3 players. So if you have one X squared and another X squared, you have two X squares. Now, right over here, I'm looking at this. I take the square root of both sides to get R. The square root of X squared I know is X, but I don't have the square root of 2, so I leave it there as radical 2. So now, what do I have? I have this is going to be now X radical 2. Oh, hold on. Hello. Are you there? You at school? Okay, good enough. All right, I love you. Have a good day. I'll pick you up later, okay? Bye. That is my son. He made it to school. He's telling me he's at school. See, school is very important. Now, these two angles I didn't discuss. Well, if this is 90 and this is isosceles, these angles are both 45. That's why I picked this triangle in the first place. Now we have to do sine 45, cosine 45, tangent 45. Sine 45, again, opposite over hypotenuse. That is 1 over radical 2. And again, we're going to rationalize the denominator. So 1 over radical 2 is the same as multiplying by radical 2 over radical 2. This becomes radical 2 in the numerator. The denominator is radical 4, which is 2. So this is radical 2 over 2. That's the way we're going to write it. Cosine 45 is adjacent over hypotenuse, x over x radical 2. It's the exact same as sine, and that comes out to radical 2 over 2. And now tangent of 45 is equal to opposite over adjacent, x over x, which equals 1. So these sine and cosine are the same with 45, and tangent is 1. So come over here. This is radical 2 over 2, radical 2 over 2, and 1. This is the table. Now when I went to high school, I memorized it. I studied it, and I practiced it, and I memorized it. But when I became a teacher, I figured out what's an easier way to memorize this table, because my students were having trouble. Well, this is square root of 2 over 2, and this is square root of 3 over 2. So I thought, continuing that pattern, could this be square root of 4 over 2? So square root of 4 over 2. Well, square root of 4 is 2, and 2 over 2 is 1. So square root of 4 over 2 is 1. Well, going backwards, square root of 4 over 2, square root of 3 over 2, square root of 2 over 2. Could this be square root of 1 over 2? And yes, it is, because this is 1. Square root of 1 is 1, therefore it's a half. And then this, could it be square root of 0 over 2? Well, square root of 0 is 0. So what you can memorize is, you write square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Now you have your thing memorized from the sine. Cosine, you just do reverse. 1 is over here, I put it over here. Whatever you put in these boxes, you reverse them. Right? Because they're co-functions. They have to make 90 degrees. So sine and cosine to make 90. You just look, if you're at 45, then this one goes with 45. Sine of 90 is the same as cosine of 0, because they make 90. So you reverse it. And then to do the tangent, just divide. You could say 0 divided by 1 is 0. A half divided by square root of 3 over 2. The 2's cancel. I'm left with 1 over radical 3. And when you radicalize the denominator, there it is. This number over this number, if they're the exact same, is always equal to 1. Square root of 3 over 2 over a half. The 2's cancel. I'm left with radical 3. And 1 over 0 is undefined. Thank you very much. This has been Radical Dude. And I hope that I was able to teach you something and that you learned something.